In this video, we're going to do a couple of more examples where we solve an equation. Okay, so here we see that we have 6 times parentheses x plus 3 equals negative 2x plus 1. Now, one thing you'll notice is that we have parentheses in the expression on the left side this time. And this brings up a point which hasn't been necessary in the previous examples we've done in the other videos, but it's coming up now, which is usually before you do anything, you should simplify each expression as much as possible before proceeding with your regular algebra. So you should distribute multiplication across any parentheses that you have, and you should then also collect like terms if there are any. And you do that on the left side, you do that on the right side. Okay, so I'm going to do that here. I'm going to distribute my 6 onto the x and onto the 3. That has nothing to do with the right side. I'm not changing this side, and I don't have to use the cardinal rule of algebra where whatever I do to one side I do to the other, because I'm not really doing anything to this side. I'm not changing it. I'm just rewriting it in, it's still going to be the same expression, but I'm just writing it in a simplified way. So I'll get 6x plus 18. And over here I still have negative 2x plus 1. Okay. So now I will proceed, and as we saw in the last video, we have x terms on both sides of the equation, so I need to do something about that. So what I'll do is I'll get rid of the negative 2x term over here, and I'll do that by adding a 2x term. Do that also here, because now I do have to do the same thing to both sides because I'm making a change. Alright, so over here I'll just get 1, because the negative 2x and the plus 2x cancel. Here I'll get 8x, and I get plus 18. Alright, so now we're down to just a single x term, and that's good. So now we'll just strip away first the 18 and then the 8. We get rid of the 18 by subtracting 18. Have to do that to both sides. So I have 8x, and 1 minus 18 is negative 17. And then this is multiplication, so I get rid of it by dividing. So those 8's cancel, so I get x, and here I just get negative 17/8. And that is my answer. You can, as usual, this is a mixed number. I can write it as a, what would that be, negative 2 1/8. Or I could write negative 2.125. These are all equivalent. All are equally correct. Okay. One more example, and this time there are fractions involved, and I'm doing an example so you see that when fractions are involved, nothing is different. It just means you might have to, the arithmetic when you're combining terms across sides and everything, you might have to do the work on the side a little bit, but it's just adding or subtracting or multiplying or dividing by fractions. So like sort of in theory it's all the same. And so let's work through this. Okay. No simplifications to be done, right? There's no parentheses that we should multiply through or anything like that. So I go right into noticing that I have an x term here, 3/4 x, and an x term here, negative 1/2 x, and I should do something about that. So what I'll do is I'll add 1/2 x, and that of course will get rid of the negative 1/2 x, but I have to do that here as well. Okay, so over here that goes away, and I'm left with 3/8. And over here I have to combine 3/4 and 1/2. I have to put those together. So maybe on the side here I'll just do 3/4 plus 1/2. I will get a common denominator of 4, so that means this one I'll multiply by 2 on the top and the bottom and call it 2/4. And so that's 5/4. 3/4 plus 2/4 is 5/4. So this is 5/4 x minus 5. All right, now I'll add 5 to both sides. Here I have 5/4 x. And here I'll have, okay, so 3/8 plus 5. All right, again, I have to maybe figure that out. Think of 5 as 5 over 1. Get a common denominator. I can make my common denominator 8, so I can leave this one alone as 3/8. And here I'll have 40/8, so I'll have 43/8. Okay. So I have 5/4 x equals 43/8. Now, as usual, I have to divide. This is 5/4 times x, so I have to divide by 5/4. So I have to divide by 5/4. Maybe just to make this a little bit easier, I'll write it this way, but it's still dividing by 5/4. So over here I get x. And then the answer to this will be my final answer. But again, maybe I need to do the work on the side here. 43/8. And I'm dividing by 5/4, and hopefully you remember from earlier work that dividing by a fraction is the same as multiplying by its reciprocal. Yeah, and maybe actually in this case I'll even do some pre-cancellation. 4 goes into 4 one time, 4 goes into 8 two times, just so my numbers don't get too big. So 43 times 1 is 43, 2 times 5 is 10. So there we go, 43/10, which is the same as 4, right? 10 goes into 43 4 times with 3 left over, or 4.3. Okay. And I didn't do it on the previous problem, but I'll do it right now. I will check, because I always should. I'm sorry I didn't do it on the earlier problem in this video. But let's check that 4.3 works here. 3/4 times 4.3 minus 5. And I'll just feed that to my calculator. And you can plug in the fraction version or the decimal version, and especially for just the purposes of checking, it really doesn't matter. And I get negative 1.775. If I do the other side, so 3/8 minus 1/2 times 4.3, and my calculator tells me, yes, negative 1.775. So they check out. They're equal to each other. Both of these are equal when x is 4.3. So that is my answer, or 43/10. Okay, so again, the lesson here is you don't do anything different with fractions. You just work through the problem in exactly the same approach, and it's just when you have to combine some fractions by adding or subtracting or dividing, you just do it the way you know how with fractions. And I did my work on the side just to keep it clean, and there you go.